Okay, today we're looking at lesson 23 and we're doing some more work with matrices. I accidentally lied to you yesterday and told you that we were finished with matrices and we were doing radicals today, but I realized I forgot a couple things. Your learning objective or I can statement is I can find inverses and solve systems using matrices. So we're going to look at a couple different things today. And we'll do some examples and I'll show you how to do some more stuff in the calculator. Now, because we are going to be going back and forth between notes and the calculator, I'm recording a little bit different today, so forgive me if there are some hiccups. Okay, we're going to start with the multiplicative identity matrix. Now, and I know my screen's a little blurry and I apologize. It's because of the different way I'm doing this today, but hopefully you can see it all right. So a multiplicative identity matrix is kind of like a 1. It's like the matrix version of a 1. If you kind of, like if we think of the multiplication or the identity property of multiplication, 4 times 1 is 1, or something like that, you can kind of think along those lines, okay? It's the identity matrix, just like 1 is an identity, is our identity number in multiplication. In the world of matrices, the identity matrix is the equivalent. So you have capital I sub 2. That means it's a 2 by 2 matrix, and you have 1s along the diagonals, okay, or the main diagonal. So I sub 3 is a 3 by 3 matrix. Again, you have 1s across the diagonal. Everything else is 0s. And then you can do I sub 4. You've got the 4 1s across that main diagonal, and everything else is filled in with 0s. And you can keep going and going, but it has to be a square matrix. So a 2 by 2, 3 by 3, 4 by 4, 5 by 5, so on and so forth. All right. And we say that 2 matrices are multiplicative inverses if you multiply them together and you get an identity matrix. Okay, and that's kind of like if you do 5 times 1/5, you get 1. That means those are multiplicative inverses. Okay, and the same is true with matrices. If you multiply these 2 matrices and get an identity matrix, then they're inverses. Okay, when we're talking about the inverse of a matrix, we say it like this. So this is the matrix A. The inverse of matrix A is A to the negative first power. That represents inverse. Okay, and a matrix has an inverse as long as its determinant is not equal to 0. So if you take the determinant of a matrix, and we did that in the calculator yesterday. So if you take the determinant of a matrix, as long as it's something other than 0, that matrix has an inverse. And the reason that the determinant can't be 0 is because when we find an inverse by hand, you have to use that determinant, and I'll show you what I mean. Okay, so if we were going to find an inverse by hand, if this was your matrix A, B, C, D, you would find the inverse by doing 1 over the determinant times this new matrix. So you swap A and D, you swap B and C, and then make those the opposite. Okay, so your determinant can't be 0 because that determinant goes on the bottom of the fraction. It's the denominator. We know we can't have a denominator of 0, so because that would make that undefined. So as long as the determinant isn't 0, you can have an inverse, and this is why. However, you're not going to have to do this by hand. You can if you want to, but it's absolutely not required. Okay, in the calculator, it's pretty straightforward. You're going to type in the matrix, and then, in the Desmos, it assigns it a letter. Then you choose that letter and click A to the negative 1 power, or that inverse button. Okay, so I'll show you how to do that really quickly. Okay, so let's make a new matrix. Let's just say it's a 2 by 2. Let's say 7, negative 5, 2, and 3. No, let's change it. Let's do 2 and 8. Okay, so I'm entering in that matrix. I'm going to hit A, the inverse. And why is that not working? Okay, I apologize. I'm not sure why it wasn't working. I think that one of my extensions on Chrome was messing with the calculator. So let's try this again. Again, I apologize. So a 2 by 2 matrix, let's just throw some numbers in there. Like, let's say 1, 4, 6, 5. Okay, so there's my matrix. I'm going to hit A. I'm going to hit inverse button. There we go. We've got some decimals. We prefer fractions. So that would be the inverse. Okay, and so that's much easier than finding the determinant, doing that, and switching your matrix around and doing that scalar multiplication. So anytime you need to find the inverse of a matrix, you can use your calculator. Okay, the next type of problem you're going to have in Math Excel, it's going to ask you if A and B are inverses. So we said up above that two matrices are multiplicative inverses if you multiply them together and get an identity matrix. So what we'll do is we will multiply these two matrices in our calculator and see if we get an identity matrix. So we'll go back to our calculator. I'm just going to clear all this out. So new matrix, my first one is 1, 2, 3, 4. That's pretty easy. All right. We need another one. This is going to be B. So -2, 1, and then 3 halves, and -1 half. Okay, so hit enter. Now we're going to do A times B. And does that give us an identity matrix? Yes. So that means our answer here is yes. Those are inverses. All right. Now we're going to do the same thing with another one. So for number 2, I'm going to give you A equals 4, 5, -2, 3. And B is 2, -6, 4, -8. Okay, so again, we'll go to our matrix calculator and we'll clear it all out. So our new matrix is going to be 4, 5, -2, and 3. Our next new matrix, you can't see it on the screen, but it's 2, -6, 4, and -8. All right, so we're going to do A times B. And does that give us an identity matrix? No. So your answer for number 2 would be no. So to figure out if they're inverses, you just multiply them and see if you get an identity matrix. Okay, so if you want to make a little note, you do A times B, and then does it equal I, or an identity matrix? Okay, now we're going to look at solving systems using matrix equations and inverses. Now, we already solved systems of 3 variables in a matrix. We typed in those coefficients and constants and hit that RREF, and that's a reduced row echelon form. And we didn't talk about what that means back then, but it's just a different form that will solve the system for you. And so you have to know how to set up a system into a matrix equation. And there could be a question like that on the ACT. So that's why we're going to look at how to set it up. And then I'll show you the easiest way to do it in the calculator. Okay, so when you're setting up the equation, you're going to have 3 different matrices. You're going to have the coefficient matrix. So you're going to pick out the coefficients. 1, 4, 6, 5. Okay, and I'm going to label that the coefficient matrix. All right, you're also going to have, or I don't know why I was making a box there. We don't need a box. We just need a matrix. You're going to have the variable matrix, which is X and Y. Okay, you can label that. And so those are multiplied, and then that equals the constant matrix, which is 12 and 34. Okay, you have to know how to set that up. you have a problem like that, maybe two, I can't remember, in Math Excel, but you have to know how to set this equation up into this equation, okay, using your matrices. So coefficient matrix, variable matrix, constant matrix. Now, if we were going to solve this using inverses, okay, if we could say this is matrix A, your variable matrix is matrix X, and then that equals a constant matrix B, okay? So we could say that. So this is kind of like a one-step equation. If you had 3x equals 12, we would just divide both sides by 3, right? Yeah. Okay, you can't really divide matrices, so instead of division, we would use the inverse, okay, because that would be the same thing. So, because you could also do 3x equals 12, you could multiply by 1/3 on both sides, and that's the same as division. So it would work out the exact same way. So we're going to do that too. So you're going to multiply both sides by the inverse matrix. Okay, we know a matrix times its inverse is an identity matrix. So it'd be an identity matrix times X. And now on this other side, what's tricky here is that inverse matrix has to always come first. Okay, and so then we know the identity is just the same as 1. So we would have X equals the inverse of A times B. And so that's what you would do. So if we were going to solve this one this way, we would do the inverse of A times B, and that would give us X, okay? So we can do that. So in our calculators, we know that this is A and this is B, so we'll do the inverse of this times this, okay? So let me go back to my calculator here. So let's say that A is that 1, 4, 6, 5. Oh, I got a little carried away there, didn't I? 1, 4, 6, 5. And our second one is, we'll just use D. Or actually, that's a little confusing. Let's just start over. I apologize. This calculator is new to me as well, so it's taken me a little bit of getting used to. So there's A, let's say B, B is 12 and 34. All right, so we said we have to do the inverse of A, so we'll do A inverse times B, and that gives us 4, 2. So our answer matrix there for that one would be 4, 2, and so our variable matrix is x, y, so that tells us that x equals 4 and y equals 2. Okay? Now, I think that's the most complicated way to do it. All right? You don't have to do it that way. All right? What we will do is we will use what we did previously. Okay? You need to know how to set this up for the ACT. All right? But this other way is easier. So let's make another system real quick. Let me find us a good one here. All right. Let's say we have 5A plus 3B equals 0, and A plus B equals 4. Okay, so this is the easier way. So we're going to make a little note that this is easier. You're going to make one matrix, 5, 3, 0, 1, 1, 4. Okay, you're going to type that in the calculator, so we'll say that's matrix A. And so in the calculator, you'll do the reduced row echelon form. And then that will give you, we'll use that to get our answer. So we'll come back, we'll make a new matrix. It is 2 rows and 3 columns. And this is what we did the other day with the 3 variables. So this shouldn't be new to you. This should seem familiar. So we've got that form, and A, and there you go. So it gives you, let me slide this over here. So it gives you the matrix 1, 0, negative 6, 0, 1, and 10. And so that tells you that X is negative 6 and Y is 10. So your answer is negative 6, 10. Okay. Oh, let me slide that back up. All right. So in your Math Excel work, you have some problems where you have to find the determinant, which was what we practiced yesterday. You have to decide if they're multiplicative inverses, and we did that by just multiplying them together and see if you got an identity matrix. Then you have to decide if it has an inverse. You did that by finding the determinant and making sure it's not 0. And then you can find the inverse by typing it in the calculator and hitting that inverse button. Then you have to solve some systems, and you can do it this way. Do it the easier way, okay, might as well. And then I think you have one problem where you have to set up these matrices, and it's going to ask you what's the coefficient matrix, what's the variable matrix, and what's the constant matrix. All right, now, I feel like this video has been super scattered, and I apologize for that. This would be a whole lot easier in person, and maybe I should have done this one live. I was thinking that it would be super easy and really quick, and that it would be easy to do a recorded video. So I'm hoping that it seems easier to you guys and more put together than it feels like on my end. But I think you guys will be okay. If you need my help, let me know. If you need me to re-explain something, tell me. I would be happy to do so. But hopefully you'll be able to figure out what to do from this hodgepodge of notes. All right. As always, let me know if you need me. Have a great day.